Hi, everybody. Welcome. My name is Adam Penna. I'm here to continue the conversation in 3D printing and additive manufacturing. I've been having some wonderful conversations with my next guest here. Greg Loughnane from University of Dayton is here with us. Greg, welcome.
Thank you, Adam. Thank you. Yeah, man. And, to your point, it was kind of crazy and serendipitous running into you. I mean, I had a mentor say, hey, have you heard of this guy out of Austin named Adam Penna? And I was like, no, I hadn't heard of him. Follow. The rest is history.
It's wild because we've had a couple really long and good conversations since then about what's been going on, and obviously we've both been going through a lot of changes. And you've recently took up, being a professor there at the University of Dayton. How far are you into that right now?
Yeah, just a couple months now. I mean, I had been teaching for the last 4 years or so as an adjunct, and actually I thought I was headed down your way to Austin, Texas.
You were here for a while, right? You were here for a little bit. We just missed each other.
Well,
right?
yeah. Well, I was actually on my way down there, but I never made it because the Rona.
Yes, that's right.
So it just was serendipitous the way it worked out with you and I. Thought I was coming down there, never made it, and then I ended up sort of circling right back around to where I started in good old Dayton, Ohio.
Yeah, and what a beautiful campus. And I mean, of course, the University of Dayton Research Institute, my gosh, to have access to all of that also. How exciting.
Yeah.
I'm jealous. No, I'm happy for you, man. That's
hey, that you got the $160 million UDRI, and then you've got the $5 billion AFRL right next door. It's just, how do we commercialize this stuff coming out of there, man? That's the goal.
And that was the big thing that interested me when I talked to you, is you were talking about the reality. A lot of, professors or academia get lost in their one little niche and then going off into that. But you look at the reality of taking optimization with artificial intelligence and additive manufacturing mixed together, and what can really happen. And so that's very exciting, because there are a lot of things. It's a very hot topic, but at the same time, it's kind of in that non-reality. It's becoming a reality, but it's not adopted everywhere, and there's reasons and bottlenecks and things that have to happen, and everybody has to kind of come together and work together to make that happen. But so wow, that's really what you've been focusing on over the last how many years now?
Yeah, really. I mean, over the last, especially the last 6 years, but I kind of was dipping my toes into 3D printing and dipping my toes into AFRL, over the past 10. And so I'm very much kind of with you on this non-reality kind of still. And there are pieces that we can chunk off and we can start to actually create value with now. And it's like, what are those pieces and why aren't more people doing it? That's my big interest here.
Yeah, I mean, that's the key, right? Is finding out where that needs to happen. One of the things you talked about that I picked up in some of your conversations were talking about via Negativa. What is it? Via Negativa? Is that right? How am I saying that? I'm not saying it right, but it's in there somewhere.
Right.
Yeah. But I mean, learning from the negative and learning from what's not there, and that's kind of where you draw the focus on what can happen, and because of what's not able to happen, and working from there. So talk about that a little bit, like
really, I gotta like give a nod to Nassim Taleb on this via Negativa idea. It's just sort of like, hey, let's go back to the simplest solution is the best idea. That's what truly optimized things are, right? This idea that you don't need to overcomplicate things, and you really need to look at the lowest dimensional problem that you possibly can if you want to find an optimal solution. And really, when we talk about these meta problems of advanced manufacturing, 3D printing, and AI, a lot of people want to promise the world away, and it just doesn't quite work, So I did that too, basically for years. I promised the world away and wrote all these proposals, and I was like, hey, NASA, I'm going to solve these grand scale issues, and you can spend $1 million, you can spend a couple million, and then you realize, man, I don't have anything for this couple mil that I just spent. But somehow you have to bootstrap a startup from a couple tens of thousands. And how do you do this? And I've really been focused on that. And I think the key is back to this via Negativa thing. It's back to this idea that if you're going to take this huge dimensionality space, right? Any machine, any material, any part, any geometry, any, scan strategy, hatch spacing, layer thickness, et cetera, et cetera, et cetera. It's like, okay, forget about that. Yeah, you can sell that, but you can't actually build it. What can we build? We have to build one thing at a time. And then we have to build, get enough data to create that algorithm that starts to get that momentum and that flywheel spinning, and then keep it going, man. From there, right? Not top down, it's bottom up. It's got to be. And that's that's the Via Negativa in a nutshell that I was trying to get across most recently.
Yeah, no, it's true. I mean, that's a lot of where things come from, and it's a hard thing to find what to focus on next with everybody throwing things against the wall and seeing what sticks. There's a reality of, hey, we need to spend our time on the right things, but then how do you know what the right things are? So it's a
Right. Yes,
it's a
that
difficult
is
learning
always
curve.
the
Yeah.
question.
Yeah,
Right.
yeah. This whole industry is based on, I come from actually metrology, CAD design, and then working now in the 3D printing industry for pretty much half of my career in one way or another.
Mm.
There's all this extra data that everyone's collecting, right? And then we have to figure out what we're doing. And I saw that so much when I was inside of metrology, because it was point clouds. Everything was point clouds. You collected mass quantities of point clouds. But then actually knowing what to really do with all of those points in space, especially when you're scanning something, say like an airplane, or you're scanning something like an inside of a building or an outside bridge. There's so much data that goes into that. So that's one aspect of it, is the data collection and what you do with it. And when you look at 3D printing, there's a lot of that going on, a lot of data collection, especially when you're trying to build something and looking how to build it, and seeing, talking about Via Negativa, is how you see it not happening, how it breaks, how it doesn't build, what happens when an error takes place. All those things are really bottlenecks in the industry, because it's kind of pushing into production right now, and that's the additive manufacturing side of it. But when you look at how we monitor and how we see things, there's a lot to be done with that data control. So I can imagine that's going to be a lot of what you've been getting into and what you will be getting into now, being at the University of Dayton.
Well, it is, and it's not in a sense, because, I've kind of been traveling this road from research, into kind of, I want to focus on development. Really, I want to focus on commercialization. And, as you get further and further away from research, you really get further and further away from this high dimensional data, right? You don't play in the super high dimensions anymore when you're not doing research projects. And like, I really love this idea from the CEO of Anaconda on a podcast recently, on the A16Z podcast recently. He said, like, data is like frozen models, basically. And I love this idea, because I came out of, data being like frozen models makes so much sense to me, because I came out of the modeling and simulation world. I got this degree in optimization. And then everybody said, well, Greg, where's the machine learning? Where's the deep learning? Where's the AI? And I said, well, I guess I better go figure this out, right? And so when I went and figured it out, I thought, okay, well, now you have all of this data-driven approach stuff, which is different than this, I know what the answer is, let me do a physics-based model. But I love this idea that data is just a snapshot of a model in time. The sensor that collects the data fundamentally operates it collects data at the time and length scales, and those wavelengths, whatever it's collecting, the physics that it's collecting are implicitly captured in whatever that frozen model is. And so you have to sort of unpack that model to be able to figure out how you can develop, the computational model, to do it in closed form, let's say, and to do it with no hardware and no sensors and all of that. And so you really have to kind of marry these two approaches to solve some of these problems. But I think it does get back to, okay, what are the things that you actually need to focus on to deliver real value for not that much money in the short term? And that's where 3D printing, I think, is finally getting to the point where not that much money is becoming a real possibility.
Yeah, it's the big quest, right? You want to lower prices and make more of everything, right? And that's that's a long that's a long kind of path that you have to take, and it's happening a lot quicker in technology. Technology actually accelerated that curve. So to think about what we need to overcome these barriers, and to kind of look at the future of, hey, additive has to step up into production, and we have in a certain way, low volume production, looking at more high volume production with a lot of the new technologies and the new processes. And I think that's a bit of the blessing and curse, because as these technologies kind of shift, you have to come up with new ways of, looking at, like we're talking about, monitoring a build, seeing what can be done on the fly as it's happening, in process, as it's called. But there's so many changes going on to actually focus on one technology, and to get all of the case studies and look at how that can happen with a particular part in a particular industry, set up for size and scale. There's a lot that goes into all of those parameters,
Yeah. Oh, yeah.
So that's a huge challenge.
Oh man, it's such a huge challenge. And I like to think about it like, kind of think of going to a machinist and think of asking them, hey, where should I put sensors on your machine, right? What's he going to say? He's going to say, like, what are you talking about? Like, I don't need sensors on my machine, right? And so what you have to do is you have to sort of say, okay, well, what's the thing about your machine that pisses you off the most, right? That you if you could automate something, what would you like to not have to do, sort of thing, and so I think it's the same thing with additive. And if we consider that a 3D printer is basically one step in a larger manufacturing process, and then that manufacturing process is one step in the operation side of the business versus the sales side, or however you want to split it up, right? There are a number of different lenses through which to view businesses these days. But zooming back in, it's like, okay, we have people that run these 3D printers. So my thing was always, well, let's go talk to them. Let's go see what they're looking for. Because fundamentally, what you're doing is you're trying to automate what the human who's running the machine is doing when he stops the machine.
Right.
Yeah. When he says, okay, problem, need to fix it. And so you need to sort of automate this problem detection, and this fixing. And that's sort of the essence of the feedback control. And so how do you automate each step of the way? Well, the first thing is you do the monitoring, and then you do the little flags, right? You're like, okay, the problem, manager, come look at the problem. And, it's the same thing. And you just sort of, so it's this weird thing where you're trying to take the human out of the loop or whatever, but you're trying to do it most of the people that run these machines these are sophisticated, background people. They don't necessarily love sitting there watching the machine run all the time. Like, they would love to have that piece of the job automated. And so the question has always been for me, it's like, well, how do we automate that? But that was more of the practical question that came out of all the sciencey investigation of, right, how do we take every different sensor modality and sort of smash it together and take machine inputs and outputs and get microstructural predictions and make sure that we don't have like 10 micron holes in the part. So there's no, potentially like crack initiation sites later in the line when it's on the airplane. And, all that's great. And all of that digital thread stuff and predictive maintenance and sort of long-term end-to-end is great. But I think when you look at how to create a startup in this space, you have to say, okay, what is the easiest possible thing that I can do to really generate value for people that are already spending money? And one of the things you can do is you can talk to people and say, hey, what's your biggest pain? And it's the way every company started, right? So makes sense.
Yeah, that's the ultimate sales goal, right? Is finding the pain so you could find the solution. But at the same time, when you're not blowing smoke at somebody, when you're actually coming up with a process that optimizes what's happening, my gosh, that's all we're looking for, is to make things better. So it's a beautiful thing when you see that in action and in theory, because there's a lot that goes on with, let's try this and let's see it fail. So right, that's the tough part.
Right.
A lot of people want to avoid that, but how do you learn if you don't see it fail?
Right. Well, and failure is the best way to learn anything. And I like this idea that research, right? You have to search, and then you have to research and search again and research again. And it's like you have to do that with everything, right? And so there's always this little sort of failure researchy period of time where you're doing a ton of learning before you can really get on that growth trajectory track. And so I think we're kind of getting there, with additive now, and with metal, let's say, on the process monitoring side. And I think that part of it was also us just getting comfortable with the fact, like, what does flight critical mean, right? Like, what is okay to put in somebody's body? What do these things mean? They were so amorphous a few years ago, and now they're starting to say, okay, well, we tried it and it didn't break, so I guess that was fine, the guy watching it, and so we can just now automate that, and we feel good about it. And so part of it is just this evolution of technology that has to occur too. So I think that it's a great time to be in the space, man. It's maybe the best time ever. Yeah. And, it turns out you actually don't need all these newfangled things that I was doing research on. Most of the time you just need an optical camera.
Yeah. Well, that's really part of it. You got to see what's happening, right? That's
right.
Where it starts. But yeah, I know there's a lot of that you started to unpack there. And I know you were talking about, there's so many things that you could provide as a service, and that whole industry of as a service is really taking off now. especially on the software side. And I know you've worked in even in the past with startups and companies like that became Open Additive that's out there. That there's a lot of what goes on in developing a startup and looking at the as a service kind of platform, the open platforms that are out there. Talk about that, like the open side of it kind of been some of the maybe the closed spots that you bumped up against and the difference between the two.
Well, really the openness of it has always been a problem. And I think that's just the nature of any kind of burgeoning industry. I mean, the people that are first movers want to kind of get out and say, okay, this is my IP, we're going to close it down. And, it was really fun for me to work with the guys that eventually created the open additive system, because they were a bunch of physicists, man. And I'm an engineer. I never have identified as, so these are like hardcore laser physicists, man. Brilliant people. And like, they're like, oh yeah, it's just a laser like this, and it goes like this, and it's just zap, 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 and it's like, oh, okay, yeah, I guess it's that easy. And so they were always okay with busting into things, right? We had to like get and vet like busting into things with the people who own the things, right? Because they're like, whoa, I just bought this, Ferrari, I don't want it upgraded right now. But it was fun because, I learned a lot about exactly how closed systems were from the software side, from the hardware side. I learned about how people felt about open and closed, especially after they spent $1 million, $2 million on a machine. And it became clear to me that like the only way that we can continue to move in a direction where we're actually innovating instead of just like, don't look at mine, IP protection and everything. The only way is to start opening things up a little bit. Once the machines became like really, really good, very reliable, the sensors were always in the same place, they were staying clean, just like the basics were figured out, right? And then once the basics were figured out, then you can go ahead and you can say, all right, well, now we can potentially, since we're, king of machines or whatever, we can kind of now open it up and we can start to say, okay, we actually need more innovation in our machines now too. So there was this kind of cycle that needed to happen. And I think that's what we're kind of seeing. And so from the open additive side, the openness is always something that's going to apply to researchers fundamentally, right? Because if you're a tinkerer and you want to mess around with stuff and you want to do it on the super cheap, then you want it to be open and you want to be able to do whatever you want. And that's just not how commercial things work. And you don't want people to go in messing with your product and break it and then call you and say, can you help me fix it? It's like, hey, you weren't supposed to mess with that. So I understand that there are these two sides that we have to balance.
You're absolutely right. That's important to point out. That's a big thing.
But, I think the Open Additive project fundamentally came out of a for researchers, by researchers kind of ethos. And in that way, we're starting to see this, I think this diffusion of innovation that we're seeing with AI and with algorithms and with programming and with software in general is really pushing it more than I think the 3D printing side on the openness vibe. I thought it was hysterical, right? The Advanced Manufacturing Olympics had open source in the morning and cybersecurity in the afternoon, right? I was like, what world are we living in, right? Like, forget that the Space Force General was just on there, but open source and cybersecurity from the Air Force and Space Force. And it's like, so the world's kind of changing with all this innovation and diffusion of like, TensorFlow and everybody giving away these AI tools. It's like, nobody knows, should I build my own? Should I just use somebody else's? Like, hey, let's just open things up and play around. And that's my kind of, intuitive sense of what's kind of continuing to happen and unfold here.
Yeah, it is. And you're absolutely right. There's a lot that's happening. And you're right. There's reasons why systems are closed down over there, especially when they're working in production. You have a certain material that works inside the machine. You have a parameter that works inside the machine. Why would you go in there and do anything about it unless you're doing R&D? But then there's the side of, hey, there's a lot that happens on the R&D side, and there's a lot that happens in a company with controlling what's going on, especially when they get larger, that they need that those two sides are both good, for what's happening to progress forward.
Yeah.
But at the same time, there's a lot going on, like you were saying, with developing that as a service side. And I see that right now as being huge, and what's happening out there. 3D printing is all been about everybody in their separate machine silos, and now you see all the software that's happening to integrate to make things better. I actually had a recent podcast with both HP and Dendrite, and they were talking about their new the new Dendrite kernel that's out there that actually has something that's attributed to each kind of generic model structure, you know, and able to accelerate the performance that way. But it's something that's wrapped around all the different machines, and the issues are always what you're talking about, dealing with IP, dealing with the company when they're not trying to open up what they're doing. But there's been more open conversations, more tools out there to unite the industry on how we could work together with standardization. You know, talk about optimization, but how can you optimize if it's not a standard procedure? Everybody's got their own different procedures and they're changing constantly.
That's it. No, that's a perfect thing to bring up, because I mean, you know, that was my whole thing as a researcher in the beginning. It's like, well, what do you mean these are the optimum parameters? Are you saying these are the uniquely global maximum or minimum set of optimal parameters? Is it the only one that would ever work? And then, you know, as we get into multi-laser and as we get into, well, maybe we'll play with the layer thickness to speed up the build time. And it's like, yeah, of course you can do that. So like, what does optimum mean? It's like, oh, and then we're back to square one. It's like, what does it mean, right? So, you know, I think that there's always this room and there's always this tug between like sort of, you know, we have it figured out, we could do better. Is it good enough to keep moving forward? Like, if the answer is yes, you probably should keep moving forward. And really, as a researcher looking at it, you know, 5 years ago, I didn't think about it that way, right? I didn't think about it from the business perspective. When I probably should have. And, you know, it's very, very, you kind of caught up, like, are you sure that's the optimum? Are you sure that's the, you know, it's like, well, who cares, man? It gets the job done. And it's like, what's the job that's being done? And why is that job being done? And I think, you know, on the company side, that's the push. And so, you know, you need companies out there that are leading the way, that are putting big targets out there that says, you know, hey, this is what we're going to deliver to you, that are really big, audacious, hairy goals, right? You know, like Dassault Systems and then, you know, ANSYS saying, okay, we're going to solve your entire digital thread problem. It's like, hey, it doesn't matter if you believe that's true or not, but I like that somebody's out there saying, hey, we're going to do this. Because if you had nobody, that's worse, right? If you had nobody, that's worse.
Absolutely. It's all those people that are popping up that are pushing that forward. And I know even 2 years ago, a lot of conversations that weren't happening are happening today because people are opening up. They're seeing the value of collaborating, growing an industry that needs to open up and communicate more. And it's happening. So that's the exciting part of it.
Yeah.
You know, it's been weird to kind of see things change. And one of the, I guess, hopeful and positive things that happened during the initial pandemic was the response from 3D printing, the response from additive manufacturing to supplement some of the things that are happening inside of supply chains. And you talk about digital thread, that's where people are starting to, you know, marry the two and understand what really is supposed to happen here, because, you know, 3D printing can do a lot for that interim kind of mitigate issue response time, and also at the end of the value chain where you're looking at parts as they kind of, you know, sunset, you know, there's different things that are made that go into their trail end where they're not stocked as much on shelves. And that's where 3D printing, additive manufacturing could come into play.
Right.
But it's been kind of a big eye opener for the public and for the companies out there to see, this is part of risk mitigation for the company. This does make sense to start looking at more of where our digital value chain and all of our digital inventory and everything that goes along with all those buzzwords out there. It's important, you know, it actually starts making sense to do, you know, it's a call to action I see happening right now for a lot of companies. So that's good.
Right. Well, yeah. And I think you've got this digital thread thing that it literally threads together all of these previously disparate, like, entities, areas of the world, right? So you've got now, like, you got in-process monitoring overlapping with non-destructive evaluation, and you've got predictive maintenance now. Like, all of a sudden, like, this is a research problem, and it's not just the reliability and sustainability guys. And you've got, you know, the planned obsolescence tugging on the how long can we make it last? And, you know, it's like from the beginning to the end, it's this ultimate abstraction, this digital thread idea. And so, like, it's very, very hard to kind of wrap your mind around each piece of it. And for any given part and the lifetime of that part, you're probably going to have a pretty different digital thread, even depending on, at this point, you know, depending on what year you create that thing, your digital thread, you know, 10, 20 years down the line is going to be much, much different. In 2020, in 2021, 22, like, these things are becoming, and it's like, what data do we keep and what data do we throw away, and what data do we collect in the interim, and where do we store that data, and how do we analyze that for anomalies in the meantime, and how do we try to predict things from it, and and then how do we use simulation to augment our predictions, and then there's an infinite amount of like really cool stuff that we could do, and that sort of everybody, I think, kind of agrees, well, we're going to continue to move towards all these really cool things, but how do we chunk off the little things that are like, oh man, that's super valuable right now. This is the time for that. And, that was a great example in the COVID-19, it's like, okay, PPE, whoop, it's time for PPE to shine. And it was like, okay, I don't think metal 3D printing has had its day yet, but I think it's coming. I mean, I think it's like, I believe that metal 3D printing is absolutely ready for prime time. And I believe that very, very few people know that. And I don't think very few of your listeners know that, but I think very few people in general know that, and very few machine shops know that. And it's like, even if they did believe that, that machine is fundamentally different than a lot of the way they can process materials now. It's like, you have to worry about microstructure. You have to worry about this sort of raw material essence stuff that you don't really have to worry about in so many other processes. And so the question is, how do you bridge the gap between the data that we can collect, the things that we can guarantee with that data, and then like making these people feel like, okay, it's ready. It's time for me to adopt that and put it into my, system of value creation that already exists. That's where we start, right?
Yep.
I think on the startup front, you got fresh PhDs coming out, they want postdocs, whatever, it's like, hey, I got this knowledge, maybe I'll start this company. That's one thing, but how do we sort of integrate it with the existing spaces and people and ideas? That's, I think, the standardization challenge. That's the challenge of really creating value and leveraging people that are already players in the game, because that's where you really need help.
Yeah, I heard you talk about that before, the generating business value at scale, and that's a lot of the question out there, where is the value and how can we scale this appropriately? And it's because of all these different variables right now, that's a hard question to answer for most companies.
Right.
But you do see the select few that are ahead of the curve, that have been the early adopters. But we're actually getting past that early adopter phase. It's kind of like, it's past, even if you're not in the game, it's too late. It's actually happening. So.
Well, yeah, and I think that's exactly right. I mean, we're sort of somewhere in this chasm crossing now. It's like, where's the beachhead, right? Sort of thing. It's like, and that's what every startup needs to ask. It's what every company scaling needs to ask. It's like, who is that person in a large corporation that has buyer privileges and power that you could sell this technology to? And what's the sell, right? I mean, that was your gig, right? Basically, is like, what's the sell to and a lot of it was very search and researchy before. And I think now it's becoming this thing like, there's enough things to point to. It's not just the fuel nozzle, right?
Sure.
And now we can point to PPE and say, hey, look, you never know where it might come in handy. And so if we get enough of these things critical mass status, then it becomes this almost like foregone conclusion that they're going to have to invest in something, and then you have to just get there first.
Get there first. And there's a lot of people that get there first, but then it's the next wave that actually takes the prize. It's a hard thing to hold on to when you're the first.
Yeah, man.
Something forward. Yeah. That's a lot of good stuff in there, man. I know.
And, well, that's that last mover advantage, right? Is like you want to sort of sit back and creep and creep and creep and then go at the right time. And it's like, when's the right time? Nobody knows, right?
No,
there's a dog game, right?
Yeah, there's a lot of just being there. So when that time comes, you're ready. But man, there's a lot of movers and shakers, and a lot of things happening, and it's an exciting time to see it.
I mean, who's going to be the Zoom of 3D printing, right? Who's going to do it, right? It's like Zoom was what, 8, 9, 10 years old, something like that, and then Zoom, right? It's like, who's going to?
Plenty of other platforms out there doing things, but when that happened, and that's a whole nother topic I could think of right there, is mostly of the free services. When it comes out, it's free, and people take advantage of the free side of it, and then understand all the benefits of what it happens with the actual process. And the next thing you know, that's their go-to product. It's a trip to see that happen. And I see it happening over and over again. And it happened with Zoom. I remember when everything was going on, my daughter's actually taking online classes for piano. And that was before it was in person. So, hey, do you have Zoom? I didn't even know what Zoom was at the time. I've used WebEx, everything else that's out there to do things, but I didn't have a Zoom account. And slowly it's become the #1 thing to go to for a lot of people. So,
Dude, that's it. Yeah. I mean, and
I
it's
should say quickly. It hasn't been slow. My gosh, it's only been, 7-8 months now. So it's wild.
Yeah, yeah. Well, and I was all open source too until I got this, UD gig here.
Yeah.
Right. It's like,
Yeah.
I mean, yeah. Now they can charge whatever they want because it's like, hey, everybody's on Zoom. It's like, you can get on Zoom or not, right?
Yeah. That's awesome, man. There's a lot of, like you were saying before, even with the networking and getting into working with people, Zoom is part of that, being able to do conversations like this. But there's a lot going on, I guess, with the power of networking. And that's actually attributed to personal growth. That's a lot of people actually looking to be, entrepreneurs, getting out there and doing things and getting involved with people. There's not a way to get in front of people right now other than video conferencing and doing things like this. So, hey, it's a whole nother way of looking at things, a whole nother way to grow, and you got to ride that wave, right?
Well, this is the education problem fundamentally. It's like, what should you even tell young people about this, right? Because hey, it's like, hey, the grown-ups don't know what to think about this either. Like everybody in academia is like, oh my God, I can't wait till it goes back to the way it used to be. It's like, man, it's not going back to the way it used to be, man. Especially 3D printing and additive and advanced manufacturing sort of touches this kind of like programming world in Silicon Valley and data science and software companies and all of this stuff. All these companies are saying, no, remote forever. Good, right? And it's like, so what do you tell young engineers to think anymore, right? It's like, hey, you better get your Zoom game on point. You have to do it.
Yeah. I actually have no, you're absolutely right. I have an upcoming podcast, Zoom interview with a couple guys from RIT, and they're talking about just that. It's just been a wild ride for them. And now coming into this game right now, going out there into the real world, they're all like, hey, a lot of it's actually becoming salespersons for themselves. It's before it was, not worrying about kind of being able to get there and do that. Now they have to actually be able to do the video interviews, be able to talk, be able to present. And it's, there's a lot of people that didn't want to do that. They didn't want to turn their cameras on, but the resistance is futile.
I know.
It's happening. So,
right. Yeah. You want to go work for SpaceX, man. It's like, hey, you got 4 or 5 video interviews. It's like, I had a student come to me recently. It's like, hey, the last video interview is like, what's the hardest thing you've ever done on Zoom? And you get and put together a presentation. You basically have to be Zoom master now, right? You not just a passive Zoomer, but like a straight up co-host status. Like that's manager now, something like that, right?
Yeah.
So yeah, I mean, that remote education piece is a real big fascination of mine. And one of the real reasons why I even took this job in the first place was to dive in, and become really, really adept at these skills. I mean, in fact, the reason I was going to go down to Austin was to try to start an advanced manufacturing ed tech business and to try to train people better on this stuff and to try to do it in a scalable way. And because, I watch 3D printing and I watch AI and I watch these spaces that are just blowing up. And if you just sit there and if you just get really in and you dig in for 1 year, just hard, like every day, you're going to know as much as anybody else knows in that industry. And, it's like everybody who's got a second career in additive, they know that. In 2 years, 3 years, oh man, all of a sudden you're an additive expert, right? And it's like students can do that in a much shorter period of time than they can actually get a degree. And so like, what are we supposed to do with that? What's the world supposed to do with that, right? How can we train people to know that, because their high school teachers aren't telling them. Anyways, that's a big.
No, it is. I mean, I'm interested in that. I hear a lot of different things going on with education, especially. I have, I have a daughter that's right in the middle. She's in 6th grade, but I have nieces that just went off to college. There's these different time periods that I have a window into of the lives of now what it is with going mostly virtual with things. My daughter's behind this wall right now in class, and I told her, hey, don't scream too loud. We can hear you through the wall. But she's usually telling me to keep that. But yeah, it's just interesting to see what's going to happen for them and how things kind of interact and people do things differently. Have you had a chance yet to actually teach the virtual classes, or how is that?
Yeah, I mean, I teach like 3 days a week, 4 classes, so like,
wow, yeah.
got 100 students a week that and and I've really been pushing all of them on getting there. I make them make YouTube videos each week, and I make them kind of like, and they're really, even in just one semester, man, their
On
level
it.
ability to level up is, because I mean, they come in and they're like, oh, I'm a civil engineer, I'm a mechanical engineer, I'm a this. And it's like, no, you're a 19-year-old. It's like, get after it, right?
Yeah,
That's it.
yeah. Hustle.
Go hard now. Do something risky. Do something where you're probably going to fail the first couple times. Just get better at it. And like the videos that some of these students create, because I do this peer review competition video, create 1-minute video smarter than a fifth grader thing each week.
Cool.
Credit to the Acton School of Business there in Austin that kind of
awesome.
got me on this, hyped down this path. They had me do it, and I was like, this is great. I just learned how to do YouTube stuff. I'm going to teach other people. And like, it was that easy. And like, these skills are the skills now that, everybody, like this idea that you should pride yourself when you're an engineer on the fact that you're totally antisocial, like that needs, you're not going to get very far with that. Even as a coder, you can't even do it as a coder anymore. You got to turn your camera on as a coder, and you got to have your sweet coder chair and your, headphones and mic and gamer stuff. And, you got to have whatever it is that you're going for in your vibe. On
Sure.
your
Sure, I find it, it's what people are passionate about and where they do want to spend their time. They could find a way to either, work in that or actually, speak about that, do some sort of video programming. I mean, there's a lot to be done with it, but it's also learning about yourself. I think it's a large part of education right now is understanding yourself, right? What you can do, how you could help, who you can network with, who's good to talk to. All these things are part of the human condition that need to be addressed. There's an ongoing need for education and security. Those are two big things across the board that even, go into 3D printing and additive manufacturing. Big time. People want to feel secure about their files. They want to feel secure about their IP. Anything that's going on is they want to feel secure about understanding the actual technology too. It's like, you can tell me it does this, but let me actually see it in action, test it, benchmarks, processes, go through a, service company to see how things work. There's so many things that kind of bring people into being educated and feeling secure about what they're adopting or what they're getting into. And it comes with that. It's in all different directions right now. It's pretty wild.
Yeah, it is wild, man. And well, I think part of what's a university for is kind of one of the things that's at the core here. Is like,
yes.
Well, it used to be for like a place to go to learn how to think, to learn how to speak, and to learn how to write. And if you can do that, you're dangerous, man. Head out into the world, right? That's what the humanities used to be. And it's like, okay, well, what about engineering, right? And it's like, well, you learn how to build stuff, right? And it's like, so there's this level of abstraction that occurs with something like advanced manufacturing or the digital thread. It's not just building stuff. It's like coming up with the idea, bringing it to fruition, bringing it into production, scaling it, making sure that you're taking care of it all through its lifetime, laying it down to die, and then circle back around. What'd you learn? Here we go,
there's a
right?
reason why that old saying is there, from cradle to grave, because it's like you're having, it's like your baby, your contribution to the world, what's come from you and now is out there and actually functioning as part of society. Wow.
Yeah.
We all have a responsibility there.
Dude, I know. And this security thing, I mean, obviously it's huge in a city built around an Air Force base like Dayton, Ohio, right? And the thing that we always talk about out here is that, I mean, cybersecurity, it's a fundamentally reactive game, right? You're not going to worry about the failure modes of the product you haven't actually built yet, right? It's just like, you can't, right? It's like, okay, get a little too long-term view there, it's like, and so that's the challenge with the security thing. It's like, you don't even know what you want to secure until you have something to secure. Then once you have something to secure, then you can try to secure it. But like, that's sort of the same problem with education. Students come in, I was having a conversation with students today. It's like, well, what exactly are you aiming at when you come into university? What exactly do you want? Because if you knew what problem you wanted to solve, then you could say, well, I know what tools I need to learn to get there. And you might go to a trade school to just learn those tools. Or you might just find an apprenticeship to just learn those tools. But the university is sort of like, okay, it's something amorphous. It's something I want this security. I want this ability to get a job. I want this thing to fall back on. I want this, I want this thing that I could still be infinite dimensionality with. I want to be able to still do everything when I get my undergraduate degree. And it's so very hard because, you have sort of on the science side, you have the how do things actually work? And then on the engineering side, you have a lot of like, well, like how do we build things to manipulate those things and how they actually work? But then, where is the question coming from of, well, why are we looking at how those things work and then how to build things to mess with how those things work? Why are we doing that, right? And it's the Simon Sinek thing. It starts with why. It always has to start with why, right? Why, how, what? It's like, come on, like this is the essence of everything. So why you go to university? How are you gonna, look at exactly what you're gonna study, and then what are you gonna do with it exactly? And like, I think that interestingly, this data science piece sort of combines science and engineering in a way that kind of has never been like this. If you think about computer science, it's very tool-based, right? If you think about physics, it's very understanding, conceptual based. And so like, how do you build tools? How do you understand concepts? Well, in order to be a data scientist and like a data scientist for advanced manufacturing, wow, like, how do you not only understand all the subject matter associated with manufacturing, materials, mechanics, and all of that, but how do you also then say, what exactly, so you have to understand, and then you sort of have the computer science, well, what tools do I need to actually do it, right? But then you have the understanding, well, maybe I could just do it, and maybe since I understand this, the simplest solution is the best. Maybe it's just a simple heuristic, right? Maybe it's a simple heuristic. Maybe that's what a rule of thumb is, right? And so, from your days with machines, right? Hey, do approximately like this. That's the rule of thumb. And if the rule of thumb gets the job done, and that's where most of the value is, you don't need machine learning. You don't need data science. You don't need all this data, right? You just use the rule of thumb. And it's like, that's via Negativa, right? And then we're back, right? So it's just always this, you want to understand the totality, but then compress it down to as low dimension as possible to really extract as much value per unit time and be that efficient, person, employee, business creator, whatever it is. I mean, that's what it's all about. And so that's, how do you educate people? Really the security is in being able to do that all the time, right?
Yeah.
Sort of the thing that transforms the world is better than the things in the world that exist already. So you want to like be the thing that can generate new things. You don't want to be the person as things, right? And so like I love this idea, and this is what I'm always trying to infuse the students with. It's like, if you want to solve advanced manufacturing problems and you say, I'm a mechanical engineer, not a civil engineer, it's like, you don't get it. You just don't get it, right?
Yeah.
It's like, so you really have to open the aperture on learning and on specificity to solve these meta problems at this digital thread level. We just cannot operate in this, you're that means you're not everything else way, like we have been for so many years. And a lot of people in this industry have learned that themselves, right? And they're like,
no, that was a big part of it. I was thinking about too, is the actual self-learned versus the, institutionally educated people that are going through things. There's a value in both sides of it. And, I was talking to someone else about teamwork. It was Jason Lopes over there from Carbon. He's just saying, hey, we all have different attributes. He comes from the more artistic side. I also come from the artistic side. I've spent a life in mechanical engineering. So there's two sides of it that clash there all the time, but they have their own attributes and strengths and weaknesses, and so you need teammates, you need other people that could help with those weaknesses. You need continual learning. You have to have the ability to question why, or at least want to know why. That pushes it forward. Education is not only in the actual, academia sense, but it's a constant lifelong thing. And I believe that's a lot of what going to, colleges actually teach you, is you're not just learning here, you're going to continue to learn. You have to have the right tools and the right discipline, which we all sometimes lack to continue to do it. It's easy to say, right? These concepts are easy, but the actual practice, you need people around you that are also interested. You need something that inspires you. And, you've done that over the last 6 months for me. We've talked in different ways. It's been inspiring to know what you've been going through. And we've shared a bit about our personal circumstances and what brought us here. And that's it. It's a continual passion to improve and to see, hey, you know, I'm human and I have my bad days and my bad moments, and things happen.
Right.
How do I look at improving next? You know, how do I look at optimizing my life so
Yeah,
that doesn't
yeah,
happen again? You know, it's not easy. It's a lot. There's a lot that goes into it, but it takes, for me right now, it takes meeting people like you who are going
yeah,
through the same
yeah.
thing, that we could discuss these things, and at least, you know, help the
Yes.
moment. You know, sometimes we don't know what's being helped. I actually, down the road, usually I go, yeah, okay, that helps me connect this thought, and now I can move forward with things. So the more people I network with and hear their sides of things, the better it gets. So
Dude, I
something
know.
like
Yeah.
that.
And just to echo like
Yeah.
basically all those sentiments, I mean, it's kind of like, yeah, you've got this thing where it's like, if you're not around like-minded people that are pushing, and like that have figured out that the key to everything is self-discipline. Like if you're not around people that have gotten there yet,
Yeah.
then you're just not getting the fuel that you need from the world, because everybody's always like, hey, like, hey,
Downer,
don't worry
downer.
about that. Don't
Yeah,
do that. Like,
no
you know,
worries.
everybody's always telling me, go get a real job, Greg. Go do this, go do that. And it's like, no. You don't understand me. You don't understand. And that was really my big pet peeve with Dayton. Overall, I thought the whole place, like, there's nobody that understands me, right? And I was like,
Yeah.
you know, but it turns out you just have to look hard. You know, you have to know that if you're this way, there are other people this way, and you can find them now easier than ever, right?
Mhm.
And they'll take your call, and you can see them, like, you know, and they're
Yeah.
just like at their house, just like you, and it's just
Yeah.
like easier than ever.
And they want to
And
talk to people. They're desperate to talk to
I
people.
know they're stuck,
Yeah.
and it's like, and I think it's so interesting now to see like the difference between somebody that's thriving, not surviving,
Mm.
versus somebody that, you know, is like, oh, I'm waiting for this to be over. I'm waiting, you know, I'm waiting to
That's the wrong
take that trip
approach.
when I retire. I'm
I've been
waiting,
stuck in that before too. I'm
you
guilty of
know.
that in my past, with things, waiting for things to pass without taking action. You know, it's like we need to take action in all spots of our life, and it's not so easy. But at least getting
No.
feedback, you need the feedback loop, and that goes back into 3D printing and
Yeah,
closed
it
loop
does.
monitoring. You need that
It
feedback
does.
loop to figure out
Yeah.
where to go next. And
Well, you got to sift through the mountain of data in the world to actually find that via negativa piece that you can then loop back in, and you're like, ah, okay, you know, I got that 1 second of energy. Now I've got enough to just take on the day, take on the month, take
it
on whatever
is.
I
It's
need, right?
all the above, Greg. Man, it's been wonderful having you here. I know we have so much to talk about. We're gonna have a part 2, 3, 4, 5 to this some other time, you know. And
Yeah.
you know, so one thing before we close too, I know that, I guess all I'm trying to say is there's a big part of us being human beings that bring us to where we are. Neither one of us are perfect, but we're learning every day new things, and it's our past experience
Right.
that we've learned from, the fun, the failure, all that stuff that kind of brings us to where we are today. And I think
Yeah.
it's so great that you are actually part of academia, giving back and teaching students what's real out there, and how to actually face that. So
Yeah.
thanks for doing that, bud.
Well, thanks, man. And, you know, as long as it, you know, as long as it lasts, I mean, you know, as long as it works for me, it works for the academic institution. I mean, honestly, I can't believe they would even hire somebody like me, but I think that speaks
Come
to,
on now, yeah.
I think it speaks to
You're the right man for the job.
you
Yeah.
know, I think it speaks to the progression of how things, of what the freaking customers want, right?
Yeah,
I
sure.
mean, the students are like, hey, we don't want these guys that haven't been in the AI and the AM games for
Yeah.
however long. It's like, we don't want
Just
the
theory.
old crusted over, you know, like, I don't care about gas turbine engines. I want to know about renewable and clean energy, right? Where's all the new stuff? And you know, even if you come in, you're, you know, a bit weird, and you know, it's like you're kind of like, okay, that guy, don't want to mess with that guy. It's like, that's actually, I think, what's needed in a lot of places. That's that innovation that comes in. And so that's what I'm hoping to keep doing here. I mean, it's not where I thought I'd be, you know, hey, but as long as it is working for me, I'm able to sort of, you know, help these students kind of find their path. And that's really my passion, is this education piece, educate them about how to be an engineer, how to be an entrepreneur, how to be a person, right?
Yeah.
How to grow up in this crazy world where everything's being automated, and you know, you can't count on anything. It's like, if you don't grow, everything else is growing without you. It's like, this is what my passion is. And so, yeah, I mean, you know, just to kind of, on that note, it's like, you know, if scalable additive education for underserved populations, especially in urban areas, you're interested in in kind of doing anything in this entrepreneurship plus engineering space. I've got an announcement coming out soon on that. You know,
100%, that's
then
awesome.
feel free to reach out. I mean, education is my bag, man. And so like, you know, I'm here to help. I'm here to be open. I'm here to talk about stuff, right?
Yes,
Not here to
yes.
steal ideas. I'm
Yeah.
here to give people fuel, man. So, you know, any of the listeners out there, man, reach out. You know, I'm more than happy to have a discussion and talk to you. And Adam, thanks so much for having me.
Yeah, definitely, Greg. It's been wonderful having you, and wonderful place for you to be doing this up at the University of Dayton. So I'm very excited for you, and thanks a lot for being here, Greg. We'll talk to you soon.
Awesome. Thanks, man.
I'm gonna be